The graphs above represent position, velocity, and acceleration as a function of time. Which of the following could describe the motion of the marble? So let's look at situation A. Rolling along the floor and then bouncing off of a wall. Well, it looks like the acceleration here is constant, and it looks like it could be something like a free fall situation. If you're rolling along the floor and then bouncing off a wall, we're definitely not in free fall, and it would not have a constant acceleration. So A doesn't look like a good candidate. All right, let's skip over B and let's look at C. If we roll up a ramp and then roll back down, as we're rolling up a ramp, our velocity would be in a positive direction and getting slower. The velocity graph here is not a positive velocity. You would expect to see rolling up a ramp that the velocity would be getting slower as it rolls up the ramp. So C doesn't look good either. Falling and then bouncing elastically off of a hard floor. Falling elastically means that the kinetic energy, momentum and kinetic energy would be conserved. So we would have a velocity where it travels down and then bounces right back up. So that doesn't work either. So that leaves us with a choice B as an answer. Let's see why that would work. If we roll down one side of a bowl and then roll up the other side, we are in free fall situation with a constant acceleration, so the acceleration graph works. If we look at the position graph, we have x equals x naught plus v naught t plus 1/2 the acceleration t squared. We can see that the position graph, the time is squared, so we would have a parabola, and that makes sense that this position graph would be a parabola, and that would work in this situation. Our best choice would be B.